taking a look at 9.4 then. 9.4, just like we've done with our other transformations, we're going to take a look at our rotations a little bit more in depth. All right, so as a quick reminder, if we are going to rotate 90 degrees counterclockwise, we said anytime that we go to do that, our rule has two parts to it. The first part says we are going to flip X and Y. And then the second part is we are going to change the sign of our new X. So if we take a look at point A, if I flip X and Y, I'm going to be at 2, 1, and then change the sign of my new X. So it would be negative 2, 1. Take a look at B. Flip your X and your Y, 2, negative 2. Change the sign of the new X, negative 2, negative 2. For C prime, flip our X and our Y, negative 4, negative 1. Change the sign of the new X. So it becomes a positive 4, negative 1. Right? And that's just a quick reminder of how we do our counterclockwise rotations by rule. So if you want to do it by rule, we're good to go. All a rotation is when we turn a figure about some fixed point. Technically, you can do any fixed point. However, the ones we're going to do is with the origin. If we were in class, I'd show you how to do the other ones. But being that we're all virtual now, the only one we're going to concern ourselves with is if we rotate around the origin. Likewise, you can rotate any degree you want. Oh, I'm sorry. That center of rotation we were talking about is that fixed point. That fixed point that a figure is rotated around. The fixed point we're going to be using, once again, as I was talking about, is the origin. Now, I did get ahead of myself there because I was starting to talk about the degrees that you can rotate. Once again, you can rotate any degree you want. However, we are going to concentrate on certain sets. And the increments we are going to go in are going to be by going 90 degrees. So we are going to talk about going 90, 180, 270, and technically we can talk about going 360 degrees. However, we're not going to venture that far into it because you should know you end up right back where you started. So, as I said, you can rotate any degree. You would need a protractor and a ruler to do so. Right? But we're not going to do that since we're all virtual right now, since I'm not going to test you on it. You're not going to get quizzed on it. Instead, we're just going to concentrate on the ones that we can work with and the ones that have rules to them. So, you can, by all means, learn all three rules. Right? For your 90 degrees counterclockwise rotation, so remember, rule of thumb is our counterclockwise. We're going to flip them and change the sign of the new X. Now, if I do that again, I'll get to 180. 180 can have its own rule if you want. Right? All we do technically for a 180 degree rotation is we change both signs. For 270, it can have its own rule. Right? You flip them and you change the sign of the new Y instead. Please make that change if you're looking in your notes. Actually, there's a little mistake that was there. I didn't proofread the chapter 4 packet very well, I guess, when I made it. But it's there. If you want to learn all three rules, that is fine. Or you can talk about doing just the 90 degrees and just do it multiple times. So you're going to do it one time for 90 degrees. If we go 180, you're going to do it 2 times. If we go 270, you're going to do it 3 times. Right? Now, as a quick reminder, once again, in the book, if they do not specify, we always go counterclockwise. On your chapter test, I will specify though. So it says graph quadrilateral KLMN with the vertices that are given there. It says then rotate that quadrilateral 270 degrees about the origin. Once again, if they do not clarify 270 degrees, means we are going to go counterclockwise. So when I look at point K starts at 3, 2. If we go 90, we flip it. Change the sign of the new X. To go 180, we flip it again. Change the sign of the new x. To go 270, we flip it again. Change the sign of the new x. So we end up at a positive 2, comma, negative 3. Or if you want to use your rule says we'll flip it, change the sign of the new y. Flip them, change the sign of the new y. Flip them, and change the sign of the new y. Right? Giving you your new points for k prime, l prime, m prime, and n prime. It is completely up to you whether you want to learn new rules or just keep using our counterclockwise rules. Just go 90-degree increments and just keep flipping them, change the sign of the new x. Each time you go an additional 90 degrees. You can also use matrices. You can see each of your rotations has its own rotation matrix to it. That 360-degree 360-degree rotation, we know it gets us back to where we started. It is known as your identity matrix because it's going to put you right back to where you were. It's not going to change any of your values. So it says your trapezoid here, D was negative 1, 3, E is 1, 3, F is 2, 1, G is 1, 0. It says find your image matrix for a 180-degree rotation. So we take our polygon matrix, and then we have our rotation matrix. If we go 180 degrees, if I scroll up, here's the one we want to use. So it's negative 1, 0, 0, negative 1. And remember, that rotation matrix always comes first. So it's rotation times our polygon. So we're going to end up at 1, negative 3, negative 1, negative 3, negative 2, negative 1, and negative 1, 0 when we multiply. All right, if you wanted to, you could graph them and take a look at what you would have. What you are getting tested on, though, is can you produce those new points? Now, and once again, a little error. Please make the little change that's there. We talked about that term isometry. A rotation is also an isometry, meaning that everything is going to remain the same. If AB is 3 inches, then A prime B prime will still be 3 inches. If AC is x plus 5, then and A prime C prime is 10 maybe, then we know that x plus 5 would have to equal 10. Right? And that's where we can get our equation to find the value of x. So that is what we talk about here when they talk about a rotation being an isometry. Those corresponding side lengths are congruent. So I need to find these pieces that match up. That 3x, if I rotate this figure around, that 3x is going to match up with the 6. So 3x equals 6 tells me x will equal 2. The 3x minus y here, the 3x plus 1 is going to match up with our 7y. So I have 3x plus y, I said it again, 3x plus 1 equals 7y. Since x is 2, I got 3 times 2 plus 1 equals 7y. I got 6 plus 1 equals 7y, so 7 equals 7y. If we divide, we get y to equal 1. All right, last thing I want to go over with you is what's called a composite transformation. And all that means is you're going to do 2 different transformations to a point. So if I started at a point, we'll call this point A. A is at 3, 2. A composite transformation does 2 different transformations. First, it's going to reflect it over the y-axis, for example. So I take that point A, reflect it over the y-axis, and I get A prime. It's called a composite transformation because then I'm going to continue going. That's just kind of a pit stop along the way. Because once I go there, then I'm going to move it again. I'm going to go right 2 and down 1. I'm sorry, right 1, and then we go down 2. Right? And that point you end up at, we call that a double prime. So your answer, after you perform this composite transformation, is where you ultimately end up, negative 2, comma, 0. Right? That would be my answer. For your homework, it is pages 602 to 603, numbers 12 to 19, and then page 612, numbers 7 through 10. Right? Have a good day. Email me with any questions.